Hello friends, welcome to my channel. Let's have a look at problem 501, find mode in a binary search tree. In this video, we're going to share two methods. The first one is based on verbose traversal, and the second one is based on the use of generator function. So here we are given a binary search tree. So what we want to do is to find the mode of the node values. So here, this binary search tree is different from the traditional binary search tree. So here we can allow less than or equal in the left subtree, and we can allow greater than or equal in the right subtree. So both the left, right, and right subtree must also be binary search trees. So that's the problem statement. So if you look at example 1, so here 1 appears once and 2 appears twice. So the mode is 2. Right? So in example 2, so this is very special, so we return 0. So the constraints for this problem are the following. First, the number of nodes in the tree is in the range, bounded below by 1 and bounded above by 10 to the power 4. And node value can be negative or 0, but it's between negative 10 to the power 5 and positive 10 to the power 5. Here is a follow-up, which challenge us to use extra without using extra space. So with that said, we are ready to look at the solutions. So first, we want to make an observation. So for a binary search tree defined here, or the traditional one, so if we do inorder traversal of the binary search tree, so the result or the results array list we get is non-decreasing. So in a traditional binary search tree, it's a strictly increasing sequence, and in the context here, it will correspond to a non-decreasing sequence. So here, actually, we can first write a solution, practice the use of inorder traversal. Actually, for this problem, so we do not need to restrict ourselves to inorder traversal. Any order traversal will do, right? But let's first write one with inorder traversal, because we are going to count the frequencies of the node values. I'm going to use collections default dictionary. So here the string is an integer, right? So next we are going to first do inorder traversal. But as we mentioned, any traversal will do for this problem. But here, first I'm going to write two versions. One is based on recursion, and the other is based on iterative. So here, let's first write a recursion format of the inorder traversal. So this is actually very simple, right? So first, I'm going to define like this: inorder. So version 1. Let's see. Here, put a root or node. So if not root, so we just stop or return. So otherwise, what we are going to do is that we do inorder traversal the root left. So after that, so we want to update the counter, right? So counter root value is increased by 1. So here the key is the root value, and the value in the dictionary is the count or the frequency. And then we are going to inorder traversal root right. So this is the one format of solution. So up to now, so actually we can call the function, let's see, inorder 1 root, and then we can actually find the max frequency, right? The max frequency equals max list. So here, let's see, max count values, right? So once we had the maximal frequency, we just need to return the node values corresponds to that frequency. So for kv, let's see, just a k. For kv in count items, if the frequency equals the max frequency, right? So this is the one way of solution. So here the space used is O of n, right, in general. So now let's do some test. So inorder is not defined. So here, let's see, I'm using version 1. So let's use version 1. Yeah, it passes the one example. Now let's look at generic case. Yeah, it passes all the cases. So next, what we are going to do is to write another one. So here, I'm going to write a iterative format. So this is also very standard. So here I'm going to define in order. Let's use version 2. So root. So what we are going to do is that I'm also going to use frequency counting. So default dictionary in integer. So here what I'm going to do is that, so I'll set the current equals the root, and I'm going to initialize a stack. And then we're going to do while stack or current, right? So while current is not null, so we want to push to the very left, right? So we're going to stack append current, and current equals current next. Once we exit this loop, we're at the very left, and then we're going to do pop, and then what we're going to do is that we count the current value and increment its frequency by 1, and next we are going to move to the right. So that's the inorder traversal. Now, what we just need to do is to return the result here, right? So with that said, so actually we can call the function. Let's call version 2, right? So let's call count. So just to update that to be inorder 2, right? So root, and then we actually do the same thing. Let's copy these 2 lines. Let's do this. Let's copy this. So let's comment out. So let's do a check. So here we call the second function, right? So tree node object has no next. So sorry, it's not next, it's left. Right, so it passes the one example. Now let's look at the generic case. Yeah, it passes all the cases, right? So this actually forms one solution format. So next, let's write another solution using the generator function so that we can save some space. Let's call this one v1. Now let's look at the second version. So the second version is we're going to use generator function. So this is actually also very standard. So first, I'm going to define an inorder function. So inorder. So I'm going to have a node or root you can put here. So then let's first do this to get an iterator. So not if not node. So we just return, right? Otherwise, so for y in order node left, so we're going to yield this y, and then we yield node value, so this in between. Then for y in order node right, so we're going to yield this y. So this way we get a generator function. So next, what we want to do is to find the maximum frequency and then return it. So for this, I'm going to initialize a result variable, which is an empty list at the very beginning. And then we're going to have a frequency and the max frequency, right, to be initialized to be 0 and 0. And let's make a previous to be none. And then we are going to iterate over the iterator of inorder result, right? So for y in order root, and then if y equals previous, right? Because we have set previous to be none, so this is not possible at the very beginning, right? So if this y equals previous, we are going to increment the frequency by 1. Otherwise, we are going to reset the frequency to be 1, start over again, in other words. So now we are going to set the previous to be the current y, right? So now let's compare the frequency with the max frequency. So if frequency is larger than max frequency, what we're going to do is that we are going to reset the max frequency to the frequency, and then we reset the result to be the y. This is the if condition. Else if frequency equals max frequency. So in this case, so we're going to append this current y to the result. So that's the problem logic. So we need to return all the modes. In other words, all the most frequent elements. So for now, we can do the return. We return the result. So this is another format of solution. So now let's do a check. Yeah, it passes one example. Now let's look at the generic case. Yeah, it passes all the generic cases. So with that done, I guess that's about it for this specific problem. So this problem is marked easy by Leetcode. However, this problem is very interesting. So here we shared two methods in this video. One is a verbose traversal. Here we used inorder traversal. In view of the binary search tree property, so we can actually consider inorder at priority. However, for this problem, any traversal will do. The second method is based on the use of a generator function aiming to save some space. So with that said, I guess that's about it for this video. Thank you.